Hi dear students, welcome to my channel. In this video, I am going to teach how to solve the given system of linear equations by using Gauss Jacobi method. So the given problem is 10x plus 2y plus z is equal to 9, x plus 10y minus z is equal to minus 22, minus 2x plus 3y plus 10z is equal to 22. So this is a given system of linear equations and we have to solve for x, y, z by using Gauss Jacobi method. So before beginning the problem, first we have to check whether the system of linear equations are diagonally dominant. What do you mean by diagonally dominant? Means numerically large coefficients are along the leading diagonal of the coefficient matrix. Let us check how to check that in the sense. First, the diagonal elements are going to be 10x, 10y and 10z. So coefficients are going to be 10, 10, 10 for x, y, z. Now let us take the first equations. So here mod 10 must be greater than 2 and 1. So obviously mod 10 is greater than 2 plus 1, 3. And similarly second equation 10, take the numerical value of x, that's going to be 1. Here the numerical value of z, that is going to be 1. So 1 plus 1 is going to be 2. So mod 10 is greater than 2. Similarly the third equations, so 10z, so mod 10, numerical value of x is equal to 2. And here it is 3, 2 plus 3, 5. So 10 is greater than 5. So it satisfies all the conditions that the principal diagonal elements are definitely greater than the rest of the elements. Hence, the system is called diagonally dominant system. So now we can go for the iteration method can be applied for the given system of equations. So to solve for x, y, z, so let us take the first equation. 10x plus 2y plus z is equal to 9. From this, I can find out the value of x. So 10x is equal to 9 minus 2y minus z. So x is equal to 1 by 10, 9 minus 2y minus z. Similarly, from the second equation, let us find out what is y. So x plus 10y minus z is equal to minus 22. So 10y minus 22 minus x plus z. So y is equal to 1 by 10 into minus 22 minus x plus z. So the third equation is going to be minus 2x plus 3y plus 10z is equal to 22. So from that we will find the value of z. Z is equal to 1 by 10 into 22 plus 2x minus 3y. So let us take that as equation 1, the value of x, and y is going to be 2 and z is equal to 3. So these equations are the initial equation, and here for the first iteration method, let us take the value. The initial value is going to be 0, 0, 0. That is, x takes the value 0, y is 0, z is 0. So using these values in the equation 1, 2 and 3, we will be getting that. So let us use here. X is equal to 1 by 10 into 9. Y I have to take that 0, it's an initial value 0, and z is also 0, and hence x is going to be 9 by 10. So x is equal to 9 by 10 in the sense x1 is 0.9. Similarly y1, so your x will become 0, so z will become 0, and hence you will be getting y is equal to minus 22 by 10, that is minus 2.2. Similarly for z is 1 by 10, x will become 0, y will become 0, so you will be getting 22 by 10, which is nothing but 2.2. So under the first iteration, we have to take the initial values as 0, 0, 0. By doing so, we will be getting the x1 is equal to 0.9 and y1 is minus 2.2 and z1 is equal to 2.2. So now let us go for the second iteration. So for second iteration, what do you mean by second iteration? Means whatever the value we got from the previous iteration, that value to be substituted in the current iterations. So the second iteration, let us use the values of x1, y1, z1. In equation 1, 2 and 3 we get. So here the equation 1 is what? 1 by 10 into 9 minus 2y minus z for the x. So here let me take y. Y, what did we get? Y is minus 2.2. So 1 by 10, 9 minus 2 into minus 2.2, and z1 we got 2.2. So that's going to be minus 2.2. So by using the calculation, we'll be getting that it is going to be 1.12. Similarly for y2, to find y2, we have to take the values of x1 and z1. So our x1 is nothing but 0.9 and z1 is 2.2. So I am substituting in the equation 2, 1 by 10 into minus 22 minus of, here the minus is coming, so minus of, and the x value is going to be, x1 value is going to be 0.9 plus 2.2. So by calculating these values, we'll be getting that y2 is equal to minus 2.07. Similarly, we need to find out z2. So go and apply the values of x1, y1 in the equation 3, and I'll be getting that 1 by 10 into 22 plus 2 into 0.9 minus 3 into minus 2.2. By solving this calculation, I'll be getting this is going to be 3.04. So we got for x2, y2 and z2. Let us go for the third iteration. So third iteration is nothing but substituting the values of x2, y2, z2 in the equations 1 and 2 and 3. So by doing so, I'll be getting x3 is equal to 1 by 10 into 9 minus 2 into, so here we got our y2 is minus 2.07 and z2 is 3.04. These values are to be substituted in equation 1 and the values are going to be 1.01 for x3. Similarly, I am going to substitute these values of x2 and z2 in the equation 2. So I will be getting y3. So that is 1 by 10 minus 22 minus 1.12 plus 3.04, and that is minus 2.008. And similarly, in the third equation, we need to substitute the values of x2 and y2. By substituting and solving, we will be getting 3.045. So the third iteration, we got the values of x3 as 1.01 and y3 is minus 2.008 and z3 is equal to 3.045. Still we can convert the equation, so we will go for the fourth iterations. So fourth iteration is nothing but substituting the values of x3, y3, z3 in the equation 1, 2 and 3. By doing so, I'll be getting that x4 is equal to 0.9971 and y4 is minus 1.9965 and z4 is 3.004. So continuing the above process, still I am going to do for the fifth iteration. I'll be getting the values of x5 is 0.9989, y5 is minus 1.993 and z5 is 2.998. So how to find out the fifth iteration? In the equation 1, 2 and 3, we have to go and substitute the values of x4, y4, z4. So after finding fifth iteration, let me find out the sixth iteration. So the sixth iteration values are going to be x6 is equal to 1.000, y6 is minus 2.000 and z6 is 2.999. And now still let me go for this another iteration, one more. So that is going to be the seventh iteration. x7 is equal to 1.000, y7 is equal to minus 2.00, z7 is equal to 3.00. So when to stop the iteration is a doubt we usually will get. So when to stop in the sense almost the values are going to be the same, then that is the last conversion and we can stop over there. For example, if we check the sixth iteration and the seventh iteration, almost they are similar. So further iteration is not required. Here we can stop, and from this, that is, we can find the solution of x is going to be 1 and y is equal to minus 2 and z is equal to 3. So this is what Gauss Jacobi method. So when the system of linear equations are being given, first we have to check whether they are diagonally dominant. The principal diagonal elements are going to be diagonally dominant. Then we can apply the iteration method. So initial values you have to take it as, that is your x0, y0, z0, you have to take it as 0, 0, 0. By doing so, you will be getting your first iteration, and then using the first iteration values in the second iterations, and the whatever the values you got for second iteration, substitute in the third iterations in the equations, and then fourth iteration, like that you can proceed. When you get the alike numbers, almost they are similar, that we have to stop the iteration, and that gives the final solutions for x, y, z. So this method is very easy, little change only in Gauss Seidel, that we'll see in the next video. See you then. Please like and subscribe in my channel for more videos. Thank you.